everyone. This video is for grade 9 students who are currently studying quadratic equations. Today, we will talk about one of the core topics of quadratic equation. And that is the relationship between the roots of a quadratic equation. So, do you have an idea what a root is? Some may say that it is a root of a tree. Or someone can answer that it can be a cause of something that happened. But from our previous lesson, a root is a solution to a quadratic equation. So, are you ready to understand this lesson? If yes, then please get your paper and pen so that you can write down all the things that you will learn in this video.
Suppose you know that the two solutions of a quadratic equation are x equals -5 and x equals 3. And you want to find a quadratic equation having these roots. In order to find the quadratic equation, we will work backwards. The following steps that we will be using is like solving a quadratic equation but in reverse order. Therefore, we will just multiply the following roots. X plus 5 times x minus 3 is equal to 0. And then by FOIL method, remember that the FOIL method is first, outer, inner, and last terms. So the first terms, x times x is equal to x squared. The outer terms, x times -3 is equal to -3x. In the inner terms, +5 times x is equal to +5x. And the last terms, 5 times -3 is equal to -15. And then, we combine the similar terms. Thus, x squared has similar terms. So, what are the similar terms? The similar terms are -3x plus 5x. And that is equal to 2x. Therefore, we can have the equation x squared plus 2x minus 15 is equal to 0. Now, consider this in a more general quadratic equation. Ax squared plus bx plus c is equal to 0. And suppose that the two solutions are x equals alpha and x equals beta. Now, if alpha and beta are the roots of the equation, then we can work backwards to generate the original equation. A quadratic equation with two solutions, x equals alpha and x equals beta, is x minus alpha times x minus beta is equal to 0. Now, this gives x squared minus alpha x minus beta x plus alpha beta. How did we got that? By using the FOIL method. For the next step, we have to identify the similar terms. And that is negative alpha x minus beta x. So, we will factor out x in these terms. We will have x squared minus alpha plus beta times x plus alpha beta is equal to 0. Now this, we will call this as the equation 1. This can easily be written in the form of the equation x squared minus alpha plus beta times x plus alpha beta. We can divide the whole equation ax squared plus bx plus c by a, and that will give you x squared plus b over ax plus c over a. We will call this as the equation 2. Now, the coefficients of x squared in x squared minus alpha plus beta times x plus alpha beta, and in x squared plus b over ax plus c over a are now both equal to 1. Recall that the coefficient of x squared is the number in front of x squared. The coefficients of x squared in equation 1 and in equation 2 are now both equal to 1. Since equation 1 and equation 2 have the same roots, alpha and beta, and are in the same form, we can write x squared minus alpha plus beta times x plus alpha beta is equivalent to x squared plus b over ax plus c over a. Now, let's have the middle term in both equations. Equating the coefficients of x gives negative alpha plus beta is equal to b over a. By multiplying negative on both sides, we will have alpha plus beta is equal to negative b over a. Let's go to the third terms. Equating constant terms gives alpha beta is equal to c over a. When the quadratic equation ax squared plus bx plus c has roots alpha and beta, we will have the sum of roots alpha plus beta is equal to negative b over a. The product of roots alpha beta is equal to c over a. Notice that it is fairly easy to express x squared plus b over ax plus c over a. So, from this result, we will have x squared minus the sum of roots times x plus product of roots is equal to 0. Example number 1. X squared minus 8x plus 5 is equal to 0. The first step is you have to identify what are the values of a, b, and c. In this equation, a is equal to 1, b is negative 8, and c is 5. The sum of roots alpha plus beta is equal to negative b over a. Now substitute the values of b and a. And that is negative 8 over 1. And of course, don't forget that we got a double negative. So negative times negative is equals to positive. So for the sum of roots is equal to 8. For the product of roots, alpha times beta is equal to c over a. Again, substitute the values of c and a. We will have 5 over 1, and that is 5. Let's try the second example. We have the equation 4x squared plus 8x is equal to 5. Is the equation in its standard form? Okay, so let's fix that. By APE, we will move 5 to the other side, and that will be negative 5. Now, it is already in standard form. So what are the values of A, B, and C? A is 4, B is 8, and C is negative 5. So again, by substituting the sum of roots, negative b over a, we can have negative 8 over 4, and that is negative 2. So for the product of roots, substituting the values of c and a, we have negative 5 over 4. For the third example, let's have x times x minus 4 is equal to 6 minus 2x. What do we have to do in order to write it into its standard form? Okay, so we have to expand the parentheses and take everything into the left side. So we will have x squared minus 4x plus 2x minus 6 is equal to 0. And then combine similar terms. So we have x squared minus 2x minus 6 is equal to 0. Now, we can identify the values of a, b, and c. And that is, a is 1, b is negative 2, and c is negative 6. Now that we have this, we can substitute the values of negative b over a as a sum of roots. And that is negative 2 over 1. And of course, don't forget that we have a double negative. So negative times negative is a positive. So our final answer for the sum of roots is 2. Now, for the product of roots, let's substitute the values of c over a. And that is negative 6 over 1. So, our answer for the product of roots is equal to negative 6.
Aha!
What if we were given only the roots of a quadratic equation? Let's take for example, the sum of roots is 4, while the product of roots is negative 7. Don't forget that earlier we have this equation, x squared minus the sum of roots x plus the product of roots is 0. Did you remember that? So, by substitution, we can have x squared minus 4x plus negative 7 is equal to 0. By simplifying, we have x squared minus 4x minus 7, and that is our final answer. Let's try another example. For the sum of roots, we have negative 4. And for the product of roots, we have 15. So again, from our equation earlier, we have x squared minus sum of roots times x plus product of roots is equal to 0. By substituting the given, we have x squared minus negative 4x plus 15 is equal to 0. Note that we have to be careful with the signs. So by simplifying, we have x squared plus 4x plus 15 is equal to 0.
So, did you learn something from today? I hope you understand our lesson. This is Teacher Leslie, and I'll see you again soon. Goodbye!